Talked about a minute ago. Another way of dealing with Hadoop stuff is called cascading. And I need to remind myself next time I do a presentation like this that anybody else talking about Hadoop, we probably need to sync slides, since the first 4 or 5 slides are exactly what he showed. So we're going to go through it kind of quick. All right, so about me. I've been doing technology for about 19 years. Prior to my current job, I was doing factory automation, warehouse management systems, food safety. So stuff in which a lot of what I was dealing with are huge volumes of data that you only wanted 1 or 2 of the items from that data, mostly aggregated. So what was your average temperature over yesterday as opposed to what was the temperature at this exact nanosecond? I'm the CTO of Silverpop, and marketing, in exchange for giving me this, said I had to add the following paragraph to my presentation. Silverpop is the world's only provider of both email marketing, marketing automation solutions specifically tailored to the unique needs of B2B and B2C marketers. So in a nutshell, we're a software as a service player. We provide a tool to allow our clients to do marketing, which is kind of like lead generation, lead management, not generation, I gotta make sure I get that right, as well as email marketing. So I've got thousands of clients, all of which have very different definitions of what their data is, what they want in their databases, what they want their reports to be. And today, none of them, or all but a few, do not talk to their IT groups. My clients and IT do not get along. So I have the challenge of how do I give tools to my end users to let them do things that normally they'd go to IT for. So I strongly believe that the SQL RDBMS world does have a place. I couldn't see doing some of the stuff we do in our real-time applications without a relational database. However, there are things that we do in a relational database, or we did, that should never have been done. I'm sorry, Oracle solves a bunch of problems for me, but it makes my life miserable when I get into 10, 15 terabyte databases with backups and recovery and flashpoints and all these other fun things that having a relational database brings. Problem, of course, is to do a lot of the stuff I want. Up until recently, I had to think about doing a data warehouse. I had to think about paying Teradata or some of those guys a lot of money. Anybody else think about Pink Floyd as soon as I showed that? The thing I teach my folks, and we got to remember, is that not all data is a nail. Just because I've got a relational database doesn't mean I should shove everything I've got into it in order to solve my problems. So I had to throw this up here after sitting there watching Kevin's presentation and realizing a lot of what I'm about to talk about is different than what he did. But at a high level, you're going to think it's the same. So Don Brown, who's sitting out here somewhere, who's been on me since the day I met him to look at Pig and figure out where Pig would fit in and why Pig would be different than what I'm doing in cascading. To quote, Pig makes the easy stuff really easy. Cascading makes the hard stuff possible. And I'm going to show you a few hard things that even in Pig, we were struggling to figure out how to do. Okay, so this is going to go fast. MapReduce, we just saw a slide about this. Only thing I like to add to this is I've always wondered how Google did what they do. I mean, if you ever updated your Blogger post and have it show up in the search engines within seconds, sometimes minutes, you got to realize that they're updating their index continually. I've always wondered how they did that. So a couple years ago, they put out the MapReduce paper. Didn't give you a lot of details as to how, lots of whys, but it got me thinking about ways in which I could apply that kind of an algorithm to the problems I have at work. Okay, so map. Again, we went through this a minute ago. I seriously was sitting in the back thinking I'm going to rewrite all my slides, but then I'd destroy my flow. So here's one of the things in the map that we think about a lot, which is how do I evaluate each row and toss those that are older than 90 days? Or that came from a specific internal IP address range, or from a specific client services application that is showing up in our logs. If I aggregate all my data together and I include my internal people doing their stuff, my numbers are skewed. So I want to weed all that stuff out, and I do that during the map. The reduce, again, we went through this a second ago. An example in my world of where we do a reduce is the bytes streamed by IP address. So in my world, I want to know when I'm talking to a specific email internet service provider, whether it's AOL or Yahoo or Google, how much bandwidth did I actually send to them? As you'll see in the example in a few minutes, it's easy for me to figure out how many mails I sent to them, but how much bandwidth I used is completely different. And operations want to know that. They want to try to get a handle around how much are we sending to specific domains, and maybe there's a different way of dealing with our bandwidth to keep our costs down. Okay, again, Hadoop, Kevin talked about this in depth. One of the things that attracted me to Hadoop in solving these problems was that Yahoo's behind it, or Yahoo uses it. They're not technically behind it, but they use it a lot. And it made me realize I'm not about to get into a piece of technology that could be obsolete next month, that the creators may decide that they're bored with it and they want to move on to their next thing. As long as Yahoo keeps saying we're behind this and we're going to support it, it makes it interesting for me as a business person to want to continue to use this technology. And as I said on my Twitter stream a few minutes ago, my picture's better. I actually stole the picture. Right, I actually stole the picture from Chris Wenzel, who is the creator of cascading. Very much the picture that Kevin had up here. So you've got my mappers, which are first reading the blocks off a disk. I go to the shuffle, which for most MapReduce things is hidden. But when you start thinking about your optimizations, when you've got large clusters, figuring out how to do that right, or possibly writing custom shufflers is important. Then my reducers write my outputs. Here's the first thing, as a developer, I was not thrilled about. I can't name what my outputs are in Hadoop. I say what directory it's in, but there could be one file there could be thousands of files, depending on what those reducers did. And since Hadoop is the one that's deciding how many reducers, today it could be 1, tomorrow same job could be 10 because he's got different resources, or he thinks that the data over here is split around a little bit differently. One of the things I'll talk about with cascading is I've got much better control over the parts. Okay, now I do stuff we didn't talk about with Kevin. So I came to MapReduce looking with business problems in mind, as opposed to, hey, this is a cool tech I want to play with. So the first challenge I had was finding some real examples. Grep the web. Yeah, okay, I kind of get that. Word count all of Shakespeare's plays. Yeah, okay, I get that. But show me something real. By the way, I wish I'd seen Kevin had done that presentation before, because that gave me some more thoughts on things I can do, because it's a real example. So the second challenge became, where do I put business logic? Do I do it in the mapper? Because there are some ways in which you can do things in the mapper that make your life both easier later, or makes your reduce almost not work because you've either pulled too much data out, or you've spent so much time in the mapper that the distributed nature of Hadoop isn't being used. The third challenge Kevin alluded to also is, what if I need to do more of these? Every example that I found a year ago when we started this was, here's your map code, here's your reduce code. But in any non-trivial algorithm, you're going to do that multiple times. And you've also got to now explain to a class of developers that you aren't just thinking about writing your code that today is either, even if you're a good multi-threaded programmer, that's fairly linear. You do A, you do B, you do C, you're good. Now you got to think about, I map, then I reduce, but my data's got to be stored intermediate to do something. Then I'm going to do a map again. You have to start thinking that way. So this was getting harder. And my fourth challenge became, I've got some non-trivial business logic. I've also got libraries of stuff that solve business problems that I just don't want to go rewrite. Some of the algorithms, unfortunately, have proven not to be distributable, and that's a challenge for anybody who's picking up these kind of technologies. Unfortunately, some of the algorithms don't distribute very well. And there's a group of folks who are spending a lot of time in the Hadoop world figuring out how to solve that. But in my world, fortunately, everything I thought of, we could multi-thread. So I found cascading. It's an open source product. It's a wrapper on top of Hadoop, again, similar to Pig, but it's also a lot more. I have to admit, I do like Java. When you all cheering before, I felt weird sitting in the back. I do like doing Java. There's so much stuff I can get my hands on quickly. Granted, some of the frameworks are really hard, but we're not going to get into a religious discussion here. So in cascading, I've got 4 main concepts to talk about. First is a tuple. Again, Kevin, you're from a different part of the country, I can tell, because in school they called it tuple. First is the tuple. So think of a tuple as a row of data being processed. Where that row comes from, where in the flow it is, it doesn't matter. This could be a line of data read off of a text file. This could be the 5th output of map. This could be the output of the 5th map reduce. It doesn't matter. Just think about, I have a row of data to be working with. Each column can be named. This is important when I use my business in a few minutes, that it's critical that I don't have to worry about, am I thinking of the 5th element in the tuple, and that's where my piece of data is stored? I can name it. So a programmer, as he's going through his business logic later, doesn't have to worry if the inputs got changed. So the input file, they flip-flop two values because the DAs thought it would be easy to get a certain way, or they changed the Apache logger criteria. I can name it, so I can access it by name now. Operations. Define what you can do on the data. They are relational-like. I know in this group, relational is a dirty word, but if you think of the way that you do develop SQL today in the basic cases, a lot of this is going to make sense. So the first is an each. For each tuple, do something to it. Again, thinking purely about one tuple. And this is where the mapper comes in. So I could have 100 concurrent processes running, all running the same code, but all that they know about is I'm processing this one row of data. A group, similar to a group by in SQL. The cogroup is a way of joining the tuple streams together without having to think necessarily about major join logic like you would in SQL. Very similar to the way Pig does cogroups as well. And then the every, which is for every key in the group or cogroup, do this. Again, I'm thinking about doing an operation across a possibly huge data set, but all I'm thinking about is a one at a time, one tuple at a time process. Hadoop takes care of everything underneath the cover, so I'm not thinking of 100 concurrent processes. How am I doing concurrency? How am I avoiding database locks? How am I avoiding X, Y? All those things you think about today. And all you need to think about with cascading is write your business logic. One of the cooler things about the operations is you can do whatever you want to within the tuple because what your output of an operation is another tuple, including adding new fields. So to give you an example, my input data from one of my systems has a Unix timestamp, but what I really need for the end is English readable dates. So within each function, I'm able to write the logic that converts those, puts it into actually two parts, the time and the day, and then outputs a new tuple. It's a new piece of data. The operations also allow you to iterate over the group to do non-trivial things. So for example, if I wanted to do a count against all of the messages sent yesterday off of my systems, one day it could be 50 million. Next day, because we're going into the holidays, it could be 100 million. I don't need to think in my logic, how am I going to manage the memory? Am I worried about my lists getting too big? What's the right data structure to use when I'm talking millions, tens of millions of data points? The way that the cascading works, each operation is given a tuple at a time, being told, though, that your block of work is whatever you grouped by. I'll show you an example in a second to make that a little bit clearer. Another cool thing is I can do multiple operations in the same function. So if you've ever done SQL and you had to do averages and standard deviations together, it's kind of hard to get your head around that. But since you're calling Java code and you're getting called a row at a time, I can do as much as I want within a function, knowing that my output is going to be a single tuple when I'm done. Any questions so far? Okay, pipes are the thing that tie the operations together. You think about a pipe as a tuple stream. So if I've got 50 operations that I'm going to work across the data set, I join them together by a pipe. I say, first I do this, then I do this, then I do that. This is important because when we get to the scheduler, you're going to see that the cascading scheduler is going to look at these pipes, is going to look at the operations, and it's going to figure out dependencies. It's going to figure out what can be run in parallel, what can't. It's also going to figure out maps and how many reduces, again, stuff I don't want to think about, but cascading is going to do it for me. Another cool feature is that the pipes can be split, allowing me to tell cascading I want to do parallel operations. Now, he may not actually do it because the Hadoop layer may decide that there's a blocking point that would not allow this to be parallelized, but as a programmer, it's a really easy concept to say, I want to split right here, and if possible, go parallel my operations. Again, I don't have to think about how do I do mapping and reducing. How do I bring the streams back together at the end since I've split off into 5 different threads? So here's an example operation. So I've got a class that's called row aggregator that does some aggregations across a row. It finds a group by field, which is, in my case, is called recipient ID name. And in cascading, the field, it doesn't have a laser, the field is the name of the column. Just like everything else related to data, the overloading of names and cascading in Hadoop and SQL, I mean, is it a field, is it a column, is it a row, is it a data point? And all those different things of reusing the same names applies here too, or unfortunately is here too. So then I define an each with a name called reformat. So for each of the inputs, I'm going to call in each function a function on it. Then I'm going to do a group by recipient ID name. And then for every group by value that came out, I'm going to call my aggregator. So at this point, I have no idea if there's one group that's going to match, if there's 1,000, if there's 1,000,000. As a developer, I'm not thinking that way. I don't have to think about how big do my lists need to be, how much data do I need, how much memory do I need to go ask operations for when they deploy this code. I just know that every time I get a new recipient ID value, I'm going to call this aggregator function, and I'm done. It's that simple. So flows are, in effect, libraries. It's a reusable group of taps, pipes, and operations. I forgot to define tap earlier, I apologize. A tap is an input. When you saw the pig thing, it had the load. That's in effect what you're doing is you're creating a tap. So it says, you say to Hadoop, everything in this directory or this specific file are the inputs to my pipe. It allows you to build libraries of functions. And this is where, in my world, with 1,000 customers, or thousands of customers, we're way over 1,000 now, who want to do similar things but want to tweak it just a little bit. Also, these are marketers. These are not people you're going to sit in front of a command line and have them put together scripts. So we need to figure out ways of giving them the power of doing these kind of things without them knowing that they're writing code or that they're generating code. And flows come into play when we get into the cascading scheduler, which I'll talk about in a second. Right now. So the scheduler. Once I've defined all my flows and my cascades, which a cascade is a group of flows, I say to the cascading library, go. And it figures out what are all the things that are dependent on what. What are all the inputs that I need to do? Where in HDFS do certain things live? Do I have one mapper? Do I have multiple mappers? Do I have multiple reducers? Do I have mappers and reducers strung together? Where do my intermediate outputs go? All the stuff that Kevin alluded to is also difficult without Pig is made simple with cascading. It also knows how to start the next step when it can. So it's not shoving all of the jobs at the scheduler and saying, you figure it out, the Hadoop scheduler. It keeps running in memory knowing that he's going to launch the next thing as he completes a step. That also allows us to do some dynamic stuff later, which I'll talk about in a second. So dynamic flow creation. Here's a use case that unfortunately easily can't be addressed in other technologies besides cascading. So this week I've got 5 input files from a client. Next week I got 10. I don't want a programmer to go in and have to change the logic to know how to parse those 10 different files. By the way, those 10 different files may have different columns this time than they did last week, because I'm dealing with a group, again, marketers, whose relationship with IT is not very good. And often what happens, they'll get data dumps. They'll get 50 columns wide when all they really want are 2 or 3. So we have the ability through the dynamic flow creation and dynamic tuple creation, I'll talk about in a second, to use metadata to open the file, create the parser to say, throw away everything except for the 3rd, 8th, and 11th field. In Hadoop, we don't load all that data past the initial each stage. We throw away everything except for those 3 items. So this week, as I said, there might be 5. Next week, there's 10. And the nice thing is that the group and the everys don't care how many input pipes there were. The nice thing about this also is if I've got a directory, I can just dump files into the directory and using a tap and cascading say, hey, everything in that directory should be the same format. Load it up and let's go. 1 file today, 1,000 files tomorrow. No logic change on our side. Here's where it gets interesting with the tuples. So right now, when most people think about writing, said, what are my inputs? If you've ever dealt with an IT organization, what are my inputs? That file's not going to change, right? If that file changes, it's going to cost you X dollars to come back and update that. Real world, that doesn't happen. Real world, somebody finds out that they've got a new piece of data that they didn't have before. Real example of this, we do reports, we give them to our end users. Our end users present them to their boss. And in those meetings, where they're presenting those findings is somebody from sales. Or it could be somebody from a completely different group who goes, hey, did you know I have X about those same people you're talking to? So I know how much they bought last month. Did you know that? And of course, marketing says no, because everybody's in a silo. So what they're able to do is come back after the fact and say, I want to rerun that report with this new piece of data. Now, if you went to your IT group today and said, I want you to add a new attribute to my data warehouse because I just found out about it, how long do you think it would take for a normal IT group to get back to you on that? Months? How many of you would have to turn around and call Anderson or Accenture or one of those guys with a big fat check in your hand to make that happen? Well, in my world, I have thousands of clients who have that happen almost every day. I also have thousands of clients that do not have even close to the same data structures. Give you an example. I have a client that what they store in their database is an email address, a frequent flyer class, so gold, silver, medallion, last time you flew. Okay? I have a different client that only has email address, total amount that they purchased last month, and how long you've been in the list. How long have you been my client? While they're 3 fields each, they're different data types, could have vastly different ranges of values, so it's really hard to put together a generic database for that. Now, Teradata, who is pitched on this, would love for me to go back and say, great, let's build Teradata for everybody. Of course, I'd end up giving them most of my revenue for this year, which probably doesn't go very well. And again, these are marketers who think reports are cheap because they eventually get IT to build them for them. IT doesn't really charge them, but in my world, I'd have to charge them. Any questions? Okay. So the dynamic tuple thing, before I move off, allows me to create new attributes into my flows without major code changes. In fact, without any code changes, because most of our reporting is metadata driven. Here's another cool thing about cascading. Mix in regular Java operations in between the different flows. I can't do it within a flow because what a flow is defining is the MapReduce steps. But if I want to go off and define a flow that does a whole bunch of calculations and outputs a small file, I can then take that file, read it in, and go hit a memcache, hit a database. I can go hit other business systems now that I've taken millions of rows down to thousands, if not hundreds of rows, and then reach off to another business system and get some additional answers. Or reach off to another business system and say, do I need to now run some more flows? So for example, look at the logic and say, if I see AOL greater than 2% as the output of this one report, I want to kick off another flow that does a much more detailed analysis. Because cascading is sitting there running the whole time, looking at what flows are running, what state they are. I can create new flows easily without having to restart all my jobs. Also, this allows me to run in a daemon. One of the problems we had with Pig, which is the problem we have with scripting in general, I want to run 24/7. I'm not an intern going, hey, I'd like to try something. I'm not an analyst going, hey, I think I'd like to figure out, go back to some of those Twitter examples, or things that somebody said, hey, I'd like to try that. My world, the reporting is around, I want the same report every month or every week, but it's against billions of rows of data. And I can't afford to sit it in a data warehouse because my clients aren't paying me millions of dollars like they are paying some of my competitors. So I'm able to have a daemon that sits there and listens on a JMS queue, that takes in the metadata, fires off the cascading flows and cascades. When it completes the job, returns an event through the JMS queue back to my business systems and tells the end user that that's where the PDF file is, or in our case, the CSV files are. So I've got a model where I've got to run 24/7, whereas in a lot of cases, in a lot of the examples we found before cascading, it was about, I'm going to write a script to try something. So here's a real example. So I'm client XYZ, who's a retailer. For the hundreds of mailings I sent last year, to the millions of recipients, and 1 million recipients a message not unusual in my world, show me who opened, how often, break it down by how long they've been a subscriber, their gender, and the number of times they clicked on the offer. Oh, and by the way, it may have started with break it down by how long, and a week later the boss comes back and goes, wow, how's this doing men versus women? Then a week later come back, oh, what about the number of times they clicked on the offer? Or it could be, hey, each of those within a few minutes of each other. So if I was doing this in an RDBMS, first I've got to have all that data in a database. And for the most part, in our world, after about 45 days, the data isn't interesting to our end users until they want to do these kind of reports. So keeping billions of rows in a relational data and paying Oracle for it and paying them for the 3-par disks that have to be extremely fast because it's sitting under Oracle versus the extremely cheap 3-par or EMC disks is a business challenge and a business opportunity as well. So I'd have to do a bunch of million-plus row joins. Then I'd have to do row counts. Since I've got 4 different things I want to pivot on, I also have to do a bunch of temporary tables. So now I'm doing DDL in my business logic, which you know your DBAs are obviously going to love you for. need lots of memory, lots of CPU, I/O. I mean, going back to operations and saying, hey, by the way, can we upgrade the fiber because the reports that we need to run on the first of each month is completely saturating our 3PAR? They're not real happy when you do that to them. At this point, money becomes the bottleneck as you add more rows and more clients. Yes, I can go to a rack cluster. Yes, I can put a bunch of clustered 3PARs underneath it. But these are reports. If this was my real-time, have to respond back to my end user within seconds systems, I can justify that money. But these are reports. If it takes 45 minutes today to run it and it takes 48 minutes tomorrow, they're not going to care. Orders of magnitude my users might care, but at this point, for these reports, they don't care. So going back to the business and saying, hey, give me another 100 of Oracle licenses, doesn't fly. So let's talk about the cascading solution. So the first thing I do is I let Hadoop parse the input files. Then I let Hadoop group all of the inputs by the recipient's email. And then I let cascading step in. So at this point, Hadoop has done most of the work. They've done the map, which is the easy part. It's getting ready to do a reduce. Instead, I'm going to let cascading do it. So the cascading is going to call the every function to look at all of the for a recipient. So remember, if you're on anybody's email list today, you probably will get a message every 2 to 4 weeks. Consider that a year, you're looking at 12 to about 100 messages. What my clients want to do is look at your behavior the whole time, not just yesterday's mailing, but across the whole year. So I need to look at each individual recipient who's only got 5 to 100 pieces of data, but there are millions of these recipients, and I want to look at each of them and do an operation against it. So I do what's called flattening the data, which is I create one row per recipient, which is the first tier of aggregation. I don't really need to know that you were sent a mailing on the 1st and the 15th and the 3rd of the next month. I just need to know you were sent 3 in the last month. So I flatten the data into a single row. So now billions of rows collapse down to millions of rows. Then I go ahead and take this flattened data and split them into pipes that I can then process in parallel. So in this flattened row, I have your time and list, I have your number of clicks, I have your gender. So what I'm going to do is I'm going to tell cascading, go ahead and in parallel do all of those calculations. I then wind up with an output file for each of the questions that was asked, which is a CSV, which I can now either import back into my RDBMS, or I can just turn around and email it to you. Or I can turn around and make it to you available through FTP. So I've got a business problem that I only run once a month that would require serious amounts of hardware and capital that today I run in some very basic code. Have we got questions? Yeah.
Are you running this in the cloud or on your own hardware?
Right now it's on our own hardware. The biggest problem with running it in the cloud was getting the data up there. Even though I've got gigabit pipes out of my data centers, EC2, for example, doesn't let me push data that fast. Also, my operations people, as we walked through this, said, wait, you want to push all that data out of my pipes, which I'm paying a bandwidth charge for? A bandwidth charge that we spend a lot of time shaping deliberately to keep down. And if I turn around and burst and blow about half a terabyte of data each day up through that pipe, my costs are going to go through the roof. While EC2 would allow me to ship them a bunch of CDs and then they would load it up, it's just not efficient for what we're doing. Also, I've already got a fairly detailed infrastructure to support my production environments. So these sit on top of that infrastructure. Last item's important. So sometimes the bandwidth to export all of the data out of the RDBMS becomes my bottleneck. So I need to get a couple million rows a day out of my database and do it as efficiently as possible. Our DBAs have spent a lot of time figuring out how to do that with Oracle bulk loaders and some of these other things. Sometimes it takes longer to get the data out than it does to run the reports because cascading and HDFS make it so easy to spread the data across so many different nodes and do all this in parallel. So, example, continued. So now the client comes back and says, hey, I've got a new piece of data I want to do a pivot on. So it's total purchase amount, or it's age. So all I have to do now is create a new pipe in the existing flow, possibly define a new aggregation if it's not a common thing like a count or a sum, and then define where the new output tap goes. The beauty of cascading is I can do all of this through metadata. So one of the things I'm playing a lot with lately is defining a metadata format that we can provide a great UI to our end users for. Again, I've got marketer end users, I don't have technical end users, who will go ahead and say, this is what I want to report, this is what I want you to report against, this is the time frame. One run could have a single pivot, the next run could have a dozen pivots. And of course, from a UI and a billing perspective, we're figuring out the ways in which we control how many pivots we let you do. So maybe you pay us additional money to get additional pivots or to run it in 1 week versus once a month, that kind of stuff. And the beauty of that dynamic flow creation is, again, in code, without writing any new code, I could create new flows and just have it run, and cascading will figure out all the dependencies for me. Okay, before I go on to this, I was going to throw a slide in this about Pig. Now, you guys heard Kevin's presentation. Pig looks really cool. I have another set of users that I have to address their needs for. These are internal folks. They're what are called account managers. So these are folks that work for Silverpop who work with bigger clients. So when a bigger client comes along and says, I need a report that either doesn't fit into a cascading model or that requires you to aggregate a bunch of other data outside that I can't let you load into your cloud, because there are security concerns. Even though it's an internal cloud, some clients still think, oh God, cloud security, there's a problem there. So those are folks who actually do know a little bit of SQL. Those are folks that are going to be able to sit and use Pig. And here's how. All of the intermediates through cascading are being written into HDFS in a well-defined format, which unfortunately is file-based, so it's kind of like going back to the A's again. So your database is actually file-based at this point. But it's well-defined, so one of my account managers can go in and write a Pig query, or we hope, we haven't trained them yet, to write a Pig query that says, for this user identifier, for this period of time, since my inputs that are in the database are well-defined, because there's only so many things you can do with our system, I want to run some what-if analysis. That way we get them the Pig-based what-if analysis, as well as being able to, in the background, do the massive data reports that cascading makes so easy. All right, so here's another example, ISP bandwidth. Our operations team wants to know what ISPs do we send the most email to. That's a really easy relational database query against our production systems to get counts. So we sent to 1,000 AOL people for BillyBob.com last week. We've got that data at our fingertips easily. Question, though, is, so how much bandwidth did we use for that? And guess what? That's not that easy. The reason is, client A could send a message that's 70 kilobytes. Client B could send one that's 350 kilobytes. You factor in something called dynamic content, in which the content of the email message that's being sent to you depends on information about you, such as you're a man living in the Northeast, you may get an ad for a sweater at Christmas time. If you're a female living in San Diego, you're probably going to get a board short, or you're going to get a surfing thing. Our clients have have code that we've written that they execute that creates those emails uniquely. So it could be a 120 kilobyte email that goes out. And operations wants to know this so that they can get a handle on bandwidth. Also allows our deliverability teams, who are all about how the messages get delivered into the ISPs, to have a reasonable conversation with these ISPs about what kind of usage of their systems do we have. This is non-trivial. Again, when you think about sending millions of messages, I could, again, build a data warehouse, which was the original idea that went down until they saw the price on it. So what I do is we load the data logs from our MTA servers into Hadoop. These are pushed into HDFS. The deliverability teams, which are the guys who are responsible for talking to the ISPs, are very interested in Pig, because most of the data that they have is very well defined. There's not a lot of, oh, and I'm adding a new piece of data to it. It's very well defined. There's just a boatload of it. So then we run a cascading job to aggregate by the destined IP the number of messages and the number of bytes. So daily I create a file that has this information in it. So right now I've aggregated millions of rows down to, tens of millions of rows down to millions of rows. So I got a daily file. I do this every day. And then once a week we run a cascading job that looks at those intermediates and generates another report. The beauty of doing this is my aggregations, which are being done daily, and even the weekly ones, can then be used for monthly and quarterly reporting, all without having to go back and change my data model. So if a client comes up and says, hey, how many messages did I send to AOL in this 45-period day? If you hadn't thought about ahead of time how to structure your data for a 45-day report versus a 30-day report in a data warehouse, that's not trivial. In this world, all you do is you change the input directory to go look at. Okay, so a couple pros and cons of cascading. The first is that it's great to be able to mix the Java between the MapReduce steps. And by mixing Java, that could be calling anything you want. So if you got some data out in a memcache, you want to do a SOAP call to a third party, you want to alert somebody and make them provide you a piece of information before the next step occurs, all that's possible. I don't have to worry about when I map and when I reduce. If you go out there and you look at the Hadoop message boards, there's a fair amount of people who are asking the question, should I do that in the map? Should I do that in the reduce? You know what? I'll leave it up to the guys that came up with cascading who know a whole lot more about Hadoop and tuning Hadoop than I ever could. Plus, there's a community around this, so when there is a question about, hey, Chris Wenzel, is this in the right place? Should this have happened as a map or should this happen to reduce? They can have feedback across lots of different clients to say, yes or no, this is the right place to do it. I don't have to worry about my dependencies. If you've ever written non-trivial multi-threaded code in any language, not just Java, you got to think, where are my dependencies? Can I actually launch all these threads knowing that the previous thread hasn't completed? Cascading hides all that for me. I can change my data definitions on the fly. And this is great when I've got a daemon sitting out there who's reading this data, running the reports daily, or running reports on as the users ask for it. So here's the con. It's a level above Hadoop. Sometimes it is black magic. You'll be debugging going, okay, why did that happen? You'll be trying to attach to one of your mappers, or you'll be looking at the output of your mapper step and not seeing what you thought would have happened. And it turns out cascading figured it might be more efficient to do it in the reducer, even though you thought it was going to happen in the mapper. And the other thing is the data should be outside of a database to get the most concurrency. Yes, you can do database taps that read out of tables, but if you've got a table that's big enough to think about doing anything in cascading with it, your database is a problem, not your ability to do concurrency. And I know I went really fast because my first few slides, which are usually where I spend most of my time talking, Kevin beat me to. So I'm Chris Curtin. Chris Wenzel is the creator of the cascading library, very responsive, both through email and on Twitter. If you want to learn more about cascading itself, there's a website. There's a mailing list off of the cascading website. Something that I've learned a lot about here in Atlanta is the Awesome Atlantic group. It's a group that originally started to talk about EC2 and talk about some of the Amazon stuff. But in those meetings now, which we meet once a month, we talk about just about everything you could think about related to clouds. Had some great brainstorming sessions in these that got me thinking about business cases I had never thought of before, and got me thinking about some uses of cascading that don't even apply to my business, but that might be a cool startup someday. And of course, O'Reilly's got a Hadoop book out there, which is, for now, the Bible on how to learn Hadoop. Any questions? Someone back there? I can't really see. I've got a light in my face. I apologize.
Yeah, when earlier you were talking about making dynamic tuples and how you get that data into your actual database client, is there some performance you do or some sort of describing of that metadata, or is it more dynamic than that?
For the most part, what it is, there's a UI that the users tell us what the columns are. Right. We'll read, in the UI, we will read the first row or first couple rows and ask them if this is a header. And that's how they tell us what the tuples are. And the beauty of doing it that way is each of my clients has a different definition of what their data files are, and I don't have to go make code changes to support it. Yeah?
Yeah, you said earlier that you're running this piece on your own platform.
Mm-hmm.
Is running bare metal, I presume, against that platform, or do you have a virtualized, like, dynamic provision VM in mind?
Well, first, dynamically provisioning Hadoop is non-trivial, so we don't go down that path. Because, yeah, Hadoop kind of needs to know about all of the nodes out there to make this work. So what we do is we have VMs that run against our existing hardware. And the operations guys keep telling me when we get to a point where I need volume that they can give me more. So I believe them. Yeah?
So have you looked at using cascading from like an alternative JVM language, such as like Groovy or Scala?
I have not. Unfortunately, in my world, my things to play with are driven by a business case as opposed to, hey, this looks cool. I would love to play with Clojure. I read about, I forget the name, there's a company out there that does a lot of cascading work that has a airline, I guess it's a quality of service airline application that's written on Clojure. And you read about what they're doing, and it's like, wow, that's great, because they're not touching Java at all. Unfortunately, I don't have time to play with it. Okay. All right, we got the first religious comment of the day. Other questions?
Actually, I think that's about all we have.
Is that all we got time for?
Yep.
All right. Well, thank you, everybody. I'm going to be at lunch and be around as well if you got other questions.